Really? I've started recording. Just what I was just asking, like whatever we have learned in the previous classes, those things are clear, right?
Yes.
And you're able to make use of the videos for any revision that you need, correct?
Yeah.
Oh, okay, good. All right. So let's start with statistics. Let me know once you see my screen. Can you see the white screen?
Yes.
So let me first ask you, what are the topics that um, you would want to cover inside statistics? Or see, the things that we have are uh, classification of statistical data, uh, like putting them in tables, tally, uh, then interpreting the statistical data, average and measures of spread, and then statistical charts and diagrams, followed by scatter diagrams. Yeah, and then we have cumulative frequency diagrams, histograms, whatnot. Yeah. So, okay, let's go step by step. First, first of all, are we clear about why do we need statistics or statistical analysis of data? And I would want to hear from you. I mean, based on whatever is your understanding, that should be fine.
Okay.
Let's see this. Okay. Um, I tell you that okay, your class has uh, 40 kids. Okay, let's say 25 girls and 15 boys. Okay, I ask you to put down how much score they got, let's say in science, in a terminal exam. You'll say, okay, fine. This is boys and this is girls. And you say, okay, one guy got 18 out of 20, another one got 17 out of 20, uh, another kid got 15, somebody got 19. Um, Likewise, somebody did not do well, got 8, somebody got again 15. And then similarly, you got put the numbers for the girls also in this table. Okay. Imagine a situation where you were not wanting to do anything in a structured way, and you said, okay, fine, 12, 13, 17. You just blindly captured the score of 50, 40 kids. Okay.
Okay.
And you just captured this information for all 40 kids like this. There's no intelligence put to it. This data is called this is very unstructured, right? I mean, you can't make out much from this information. You
Yeah.
don't know who is the person who got 18. Was it a boy or a girl, right?
Yeah.
Who got 13, or how many kids got 13? uh, Whether boys got 13, um, I mean, more boys got less marks or girls got less marks, you don't know. So that is where it is called unstructured data that doesn't give you any intuitive view of what you're dealing with. Okay, so that is where the statistics or understanding of the data becomes more important. How do you read the data? How do you interpret? How do you use it to be able to make some decision? Now imagine, let's say, think about a CEO of a company who has 1,500 employees or 2,000 employees, and he wants to know how is the performance of his company. If the profit goes down, what decision he has to take, whom he wants to remove from the team, whom he wants to move across team. All that information for a CEO, if he or she has to look at in details about 2,000 employees one by one, it's a very tiresome job. And then he or she may not be able to make that decision. He may not have that much time also to do so. So that is where structuring the data in a certain way to make it more intuitive and then derive decision out of it is very important. And that's what statistics helps us with. Is
Okay.
this background okay?
Yes.
Yeah. So now let's start thinking about the uh, next steps. The first thing that we need to know is whatever data or information you have to categorize them. Look at this plotting of data where I just mentioned the kind of captured the numbers or marks scored by kids one after another without any grouping, any classification, versus this table above where at least we have some classification saying, okay, fine, this box of the table has score of all the boys, this box of the table has score of all the girls. Yeah, at least you have done some classification here. Yeah, correct.
Yes.
So we have done some grouping. So let's say tomorrow if you have to build some interpretation out of how the girls performed, you'll only look at this piece of the data and you will not waste your energy looking at this side. Yeah. So that way you're actually saving your time for your analysis. Yeah. If you have to look at only girls data, you will look at this side of the box and look at all the marks. So at least you are avoiding wastage of your time for looking at these 25 records. Yeah. So this is the first advantage of statistics. It helps you categorize or classify data, put them in a certain way so that you can look at only what you want to look at in a very effective way.
Yes. Okay.
Yeah. Now you can think of different situations, right? I mean, let's look at this. So let's say if you had this inside this box, if here you put boys data and here you put girls data. If you create two more child boxes here, okay,
Mhm.
and then say this is the high marks. Let's say the total exam was for 20 marks. All the kids who got high marks, meaning 15 plus, you will put here. One got 16, one got 18, 15, another kid got 15, let's say, one got 8, 19, one got 20 also. And then you put here, let's say, all the ones which is below 15. 10, 9, 8, 7, 6. Same thing, same way you can do for girls also. Now, this is even more structured. You have done further classification of data, right? Now, tomorrow somebody says, how many kids got more than 15? You will only look at this box, use this box, and you have the information. Okay. Same way, if the kids got less score, maybe because the topic was not taught well before the exam, and you see this count and this count is more, it's easy for anybody to look at this information and derive some conclusion from it and then exercise obviously. So all the data that we see around us, now you can imagine you would have looked at the weather report also, right? That gives you month on month breakdown of how the temperature is fluctuating in different cities, right?
Yes.
Yeah. So all that information that we see around us, that is some sort of a structured report with some classification of data so that you can only look at what you want to look at and what gives you a very intuitive view. And we use tables, we use charts. All these are tools and techniques for getting that structured view of the data. Okay.
Okay.
So this is just the theory part of it. Um, any questions so far?
No, not yet. I don't think no. It's good.
Okay. Okay. So for what we have now kind of looked through so far is only to understand and digest the fact that when we look at any data, if it is in a very unstructured form, scattered all over the place without any categorization or classification, it's very difficult to interpret or derive some meaning out of the data. And that is where the role of those tools which helps us to structure the information, put that in some format which is easy to read or make it more intuitive, that is what we will talk through in the classes hereafter. Okay. So and the tools that we can think of or that we see around us are different types of tables, right? Where you put data based on different groups, like what we just saw a glimpse of. Then you have charts, different types of charts. You would have seen bar chart, pie chart, histogram, line plot, dot plots, scatter plot, whatnot, right? So we will talk through those. Okay. So this is, and all that we are doing, all the different types of tables, charts, graphs, all that we do is with only single purpose of making the data look intuitive and easy to derive some conclusion out of it. Okay.
Yes.
Okay. Now, and it helps you get some trend. Now let's look at a simple example. Let's say somebody says population of India every 10 years. Let's say 1950. Okay. Let's say this was the 30 crores. Then 1960, 45 crores. Okay. I'm just making it up. Okay. 1970, 49 crore. 1980, maybe 47 crore. Yeah. Let's say 54 crores. Okay. And so by looking at this data, this is just giving you the view of the population of India every 10 years. So by looking at this, you can see that, okay, there has always been an upward trend. The population has been growing, yeah, every 10
Yeah.
years. And in 1980, this came down by 2 crores. What was the reason? Was there some pandemic? Was there some major losses of lives because of some reason? Or was it because a lot of people immigrated from the country? So, but just by looking at this data, somebody can make out, okay, that yes, growing population every 10 years, it's something to be happy about, something to be concerned about. And how do we, kind of, if somebody has to act on it, what to do? Similarly, if there was a dip in the population in a certain year, what was the reason for this? And they can find out, once they find out the reason, they can come up with action plan. So any data that we look at, it is meant for a purpose to derive interpret. I mean, you would have heard about the elections happening in India. There also you would have seen different political parties getting, I mean,
Yeah.
I'm not sure how much interested you are in politics, but yeah, you would have seen different formats of data being presented to people from which they can derive some interpretation and kind of build their opinion about it, or find out what is to be done next. Yeah. So that's the whole purpose. Now let's look at, so two things that we have looked at. One is, why do we need statistical analysis? How does it help to classify the data and then make it more meaningful? And then how do we read and interpret the data to, now, next part is interpreting statistical data. So now let's look at few tables and graphs, and you tell me what do we understand from this. Let's say I have a table. Okay,
Mhm.
just a second. I have a table which says height of people, okay, height of kids from different age group. Okay, 5 to 10 years, 10 to 15 years, 16 years plus. Okay, and this is boys and this is girls, and this is the average height. Okay, so I'd say 5 to 10 years, let's say 3 feet 8 inches. Girls, 3 feet, let's say 7 inches. Okay, now 10 to 15 years, we say, okay, fine, it is maybe 5 feet 12 inches. This is, let's say, 5 feet, maybe. This is also, let's say, 12 inches. No, 12 inches, it will become 6 feet, 6 feet. So let's put it this way. And then this is 5 feet or 6 feet, 1 inch. This is 6 feet. I'm just making it up. Just by looking at this data, if you look at this table, there's a lot of information in here. But then the advantage that you have is, just by looking just by a glance of this table, you can make out, okay, this is how my data is structured. You can digest this information very quickly, that okay, this is the age group, and this is the average height for boys, this is the average height for girls, for different age groups. Now imagine this being put in a story, a paragraph with the same information. Okay, if somebody starts writing it, kids with age group from 5 to 10 years, the average height was 3 feet 8 inches. However, this is not fixed. Similarly, for girls, it was 3 feet 7 inches. Don't know what was the reason for that 1 inch difference, but still, no, this was the average that was found out. And then, likewise, I keep on extending my story. Trust me, it will get boring, it'll be non interpretive, and then it doesn't actually solve any purpose. So this is one example. Now, same thing like the population thing that we looked at. Now let's compare that with COVID story. I'm sure you would have seen the report that was, flashing every now and then during the, pandemic days. Say, okay, fine. Let's say for a country, let's say US or India, whatever. This is the Jan month data, Jan 20. This is Feb month data. This is March data, second month, third month. This is April data. This is May data. Okay, this some count. Even if there is no count, just by looking at this is essentially called a bar chart, as you would be knowing. Just by looking at this data, you can see that okay, January month it was this much. February there was a spike. It increased. In March it came down. Maybe because there were vaccines available. People started using it. But again, April it went up. Since people started using vaccine, why would it go up? Maybe there was another variant that came into play, right?
Yeah.
So just by looking at this data, this bar chart, without reading a lot of story around it, you can simply interpret that yes, by looking at this information, I can build my own opinion about it, build my own understanding about things, and then that will help me find out what was the reasoning or root cause for it, and what is there for me to take away, right? For people like you and me, it was just an information. Maybe for doctors this was a different information. They would say, okay, fine, my this thing was because of the mutation of the virus, that's why it went up, and it is still going up. That means I need to have a vaccine which can control this mutation, right? So when the doctor looks at it this way, when the insurance company looks at it, like, they say, okay, my insurance premium will keep on going high because more people are falling sick. So the same information being looked at by different set of people to derive different interpretation and externalize it accordingly. Yeah.
Yeah.
So see, this data, while this data looks very innocent, but this has a lot of meaning for itself for different people depending on how they are wanting to look at it. Yeah. So that is what is interpretation of data. So how do you look at the statistical data and how people interpret it based on their intent, based on their role, based on their objective, based on the purpose it fulfills for them. Yeah.
Yeah.
So far so good.
Yes.
And same thing holds true for the data that you look at, be it unstructured, be it structured. If you look at unstructured data, when let's say, imagine the same COVID information for the insurance people. If they had to look at unstructured data because there was no structured data available, they would have spent more time to interpret it and then deal with it. Same way for people like you and me to get this information. Okay, oh, COVID is increasing, so we need to put more precautions in place. Use masks more often. Don't go outside where there's a lot of crowd, right? So depending on whether it's structured or unstructured, people spend less or more time and then derive the interpretation based on their needs, based on their objective. So that is what is called interpretation of statistical data. So be it unstructured, but be it unstructured or be it structured, in both the cases, people read the data and then derive their interpretation. That's the main objective. Otherwise, this data is of no use. Yeah.
Yeah.
Okay. So then we'll start talking about averages and measures of spread. So far, we are okay with what we are trying to achieve, right? I mean, why do we even need to worry about statistics, right? That part is clear.
Yeah.
Okay. Now let's talk about the averages. See, when I was showing you the boys versus girls age, no, sorry, height against the age range, right? I was not giving you the absolute numbers. I was giving the averages, and averages is what we end up dealing with quite a lot, because that that is what gives you a, what you call a, a a strategy or a plan to work on. Now let's imagine that, okay, if we have to look at the average height of kids in India versus China versus any European country or US. So you will see that the European countries or US, there the average age of kids, average height of kids is more, because of maybe the genetic reasons, maybe because of the climate. Yeah.
Yeah.
So here the kids are comparatively taller, versus if you look at the the high average height of kids back in India or China, you will see that there the average height of the kids is lower compared to American or European kids. Maybe because, I mean, what will be the reason, right? I mean, genetic reasons are this one. Same way. So that actually helps people to kind of get a view. Let's say if you have to plan, I mean, now you will ask me why uh, table tennis is a national game for China. Maybe there was some statistical analysis done, because people found out that, okay, table tennis is a game that needs skill, not height, compared to basketball. Imagine China, kids from China or India, they preparing themselves for to play professional basketball. It needs average height to be much more, correct? So basketball may not be the right game for for the kids from Asian countries. When Europe and US, obviously the average height is more, so that's why they are into that game. So all this data information that helps you build the interpretation. So and an average is something that gives you a kind of a trend. Yeah, let's say uh, 40 kids went for a math exam, and everybody got different scores. So let's say for 40 kids, if the exam was for 100 marks, okay, if average of all the kids is, let's say, 80, okay, average marks is 80, or versus average marks is 40. So I'm giving you two situation, okay? So 40 kids went for the exam. Let not confuse you. 40 kids went for a math exam. Average marks obtained by all the kids is 80. This is one situation. Second situation is average marks scored by all the kids is 45. Now, when the teacher looks at this information, or when the school principal looks at this information, he or she will say, okay, means in general, kids are performing well, because overall average marks is pretty high.
Yeah.
If average marks is less, that means kids are not performing well. Maybe even in this situation, there would be one kid who has got 100, and there could be one kid who has got 1. Here, when the average score is less, that means the lesser score obtained by kids is
Yeah.
more, actually. Wherein here also probably with the average at 80, maybe there was one kid who got only 5. Yeah. But that averages it out. So that helps you get a trend that, okay, if my average is more, that means I'm talking about a bigger number. If my average is less, that means I'm talking about a smaller number. Let's look at what are the different averages that we talk about. If first one is called mean, not the mean, somebody who's bad and mean. Mean is the mathematical mean we are talking about.
Yeah.
So, um, are you clear about how do we find the mean?
Yes.
The mean is nothing but the average. As simple as that. If I have 10, 15, 18, and 20 as four numbers, somebody says mean, just add them all and divide that by the number of numbers 2, 3, 4. So divide that by 4. Simple, right? I'm not
Yeah.
going to spend time on this one. This part should be clear, right?
Yes.
Then comes median. Do you know how to find the median?
Yeah.
Okay. I'm just checking, okay? So if you're comfortable, I would not bother you.
Okay.
If you have to find out the median of this, what will be the median? What will you do?
No, first you have to place them in the correct order from smallest to largest.
Mhm.
The number that's exactly in the middle. So in this case, that would be 12.
I'm just following your instruction and doing it, okay?
Yeah.
What will the median here?
It would be 12.
This 12 or this 12?
The one in the middle.
Okay, okay. Sorry, I'm having my breakfast also simultaneously. Yeah, so here the deal is what you said is right. There are two situations that you might end up dealing with. One, when you are dealing with odd number of numbers. Or second situation is when you're dealing with even number of numbers. Meaning, let's say if I have 1, 15, 8, okay, three numbers, and I have to find the median for this. First thing is you'll arrange them. So it will become 1, 8, and 15. Yeah,
Yeah.
and then you'll find out the middle number.
That's 8.
So when you're dealing with odd numbers, finding the middle number is easy. Let's say if you're talking about 1, 2, 3, 8, 15, 17, and 19. There also this 3 plus 3, 6 plus 1, 7. 7 numbers. So finding out the median is easy. You'll find the fourth number, which is exactly in the middle. Yeah.
Okay.
But if you're dealing with even number of numbers, meaning you're dealing with 12, 16, 18, and 20. This is where you don't have a middle number here because there is no number left to that and right to that is same count. Yeah.
Okay.
Which one is the middle number here? Difficult to find, right?
You'd have to add the 2 in the middle, then divide them by 2.
Exactly. So you will treat this as one number, and so that this side and this side you have same count of numbers. You find the two in the middle, and then average it out. 16 plus 18 by 2. You find out the average of this. That is what is your mean.
Okay.
Sorry, the median. Yeah. Okay. So only thing to remember is if you have to find out the median of an even number of numbers, you will find out the two middle numbers and then find out the median. Let's say if you are talking about, I'm just arranging, I have already arranged them in the increasing order so that we don't have to do any sorting here.
Okay.
Uh, 10 and 12. So here we have six numbers. We don't have a middle number. So I will keep these two aside and these two will be my center numbers, right? So
Yes.
7 plus 8 by 2 is what will be my median. Yeah.
Yeah.
Now mode. Do you remember what is that?
It's the number that there's the most of within like the group of numbers.
Right. So if you have what is the mode?
The mode would be 7 and 9. 7 and 9.
7, 9. So let me not confuse. Let's say if this is the case, my mode is,
9,
and if this is the case, my mode is
7.
7. So simply put, it is always the number that is occurring maximum number of times in a given set of numbers. Yeah. Now think one more step beyond. Why do we need to even worry about mode? I mean, what purpose does it solve? Any thoughts?
Um, I'm not sure.
Okay, so mean, it's easy, it's the average, right? Now, median, again, it tells you somewhat like an average. Yeah, like find arrange all everything in an increasing order and then find out something that is in the middle, which is more like an average. Yeah.
Um,
um kind of, right?
yeah,
Now when you look at mode, this also is another form of an average, you can say. I mean, in layman's term. Okay. Now if
yeah,
you look at this one, if you will take out the average of this one, in most scenarios, the your average will be somewhere closer to this, because this number is occurring maximum number of times. So this is something which is influencing the average of that set of numbers. Okay. So that is why, let's say if you have 1 3 7 8 7 7 7 2 7. So this, here you are seeing that 7 is happening maximum of time. This is your mode. And this also defines a general trend. Let's say in an exam of 20 students, if 10 students got 80 out of 100, 80 is your mode. And that tells you that, okay, most of the students are getting 80. Yeah. So that helps you derive what is my general trend, what is the expected behavior. So if I have 20 students, in that 20 is my mode. If I have to look at, if I have a 21st student, then the chance of that person also getting the same 80 is high. Let's say we have 3 plus c plus 3, nine students here. Okay. And nine numbers here. If I have to add one more number between 1 to 9, which number has the highest possibility? Obviously, since 7 has been happening so many times, most likely the next number also could be 7. Yeah.
yeah,
So this also kind of gives you a trend that, okay, what is recurring most number of times, and if in that set one more thing has to be added, this is my likely addition to that set. Yeah.
yeah,
And if you want to play around with this, you will find that in most of the scenarios this will be your average also. When whichever is your mode, that will be closest to the average of that set of numbers. This will not, neither will this be. Okay. So if any number is happening maximum number of times, or any number is the mode in a set, that is most likely the one which is closest to the average of that set of numbers. Okay.
yeah,
Okay. Are we clear about it? So we looked
yes,
at mean, median, and mode, and everything you knew. There's nothing that I have taught you just now. Okay. We are just doing a revision of what you already know. Yeah.
yeah,
Okay. So we now then, since you already know this, there are things to be learned, like calculate an estimate of the mean for group discrete or group continuous data. So how do you find out the mean or calculate the estimate? So see, if somebody says calculate an estimate of the mean for group discrete or group continuous data. So one scenario where you have something like This this is a discrete data. Okay.
Yeah.
And second is group continuous data. Here it says find out the an estimate of the mean. Estimate of the mean. Okay. What is possibly the mean of this data? You're not finding out the mean. What you have to find out is probably the median or the mode. It's just an estimate, right? Here, if you see what will be the median here, average of these two, which will be 3.5. Yeah, this is the this is the median. This is you have not
Yes.
taken out the average, but if you find out the mean, what will be the mean? 7 plus 4 11 plus 4 15 plus 3 18 plus 2 20 plus 1 21. 21 divided by 6. See, 6 3 is 18, 5 3. 3.5. See, your average, your mean, and your median both are matching here. So instead of doing this whole calculation, what you did was you just arranged them and found out the median. That gave you the estimate. Yeah.
Yeah.
Same thing. If even if you would have used mode, whenever you have to do estimate, that is when you're not actually find out the mean, actual mean. You're finding either the median or the mode. And the reason being, you don't have to add all the numbers. You have to just arrange them and deal with the mean, the ones in the center. Or you could have still tried to be a little more lazy, saying, okay, fine, I don't want to do any calculation. I will just arrange them. And what is my mode here? 4. So my estimate will be around 4. And that would have been right as well, depending on what are the options you have in the question, right? If you have a multiple choice question, you have 3.5 or 4, you'll find out which one is the closest to that without doing any calculation. You just arrange the numbers and that's it. Yeah, make sense or no? Riddhi, are you with me so far?
Yes.
Okay. So see now there's another way of looking at it. When you talk about an estimate versus actual, mean is mean. That is an actual. You're taking all the numbers, adding them together, finding out the average. When you're looking at median mode, this is also something closer to this, but more of an estimate. It gives you a trend, possible trend, or possible uh, s- you know uh, average of that set of numbers. See, this one gave you possible average. Okay, 3.5. Apparently, that matched with the mean, but if you look at the mode, that is also closer to the average to closer to the mean as well. Yeah. So these are the estimates or the possible ways to find out what is my average of the given set of data that I'm dealing with. Yeah.
Yeah.
Okay. Now, then comes the next thing, which is more about the charts and diagrams. Okay. So that's what we will focus on, and then we'll look at different types of charts. And see again, when you look at the charts, these are the most interesting, easier things to deal with. Okay. You don't trust me. No matter whether you're in 10th grade or college or doing your masters. Okay. Charts are supposed to be simple, where you have two axes here. On one side, you plot the numbers, and this is where it gives you the value. Let's say if this is the amount of milk consumed by, let's say, one child, average no liter of milk consumed by a child across months. So let's say January, February, March, April, May. Let's say we are plotting the data for 5 months. January, the kid consumed, let's say, 1, 2, 3. So 3 liters of milk per day. Okay. I'm talking about a grown-up kid, okay, who needs
Okay.
to to keep himself or herself healthier for doing some sports, let's say. Okay,
Yeah.
so 3 liters. This is 4 liters. This is 2.5 liters. Let's say this is 2 liters. This is again 5 liters. So see, if you're looking at this chart, this is called a bar chart because these are like bars, right? The candy bars that we eat or the ice cream bars that you would have enjoyed a couple of times. Yeah. So these looks like bars. Yeah. Or the granola bars that we eat, right? Protein bars. So these are like bars standing next to each other in a more structured way. Yeah. And this helps you plot these numbers. This is called a bar chart. Just by looking at this chart, you'll be able to make out that, okay, fine. See, the kid was consuming, see, there has been some fluctuations. If you look at this data, then okay, in the month of March and April, probably the kid was consuming less milk, but January, February, and May were good months where the kid was more conscious about how much milk he or she has to consume. Yeah, and this is an outlier. Here, by looking at this chart, also you can say, okay, fine. Though there were some outliers in these 2 months, but yeah, average is like 3 to 5 liters is what that the sports kid consumes. Yeah, so there's nothing fancy about it. We just need to know that this is called a bar chart, which helps you plot certain behavior against time and how the trend has been. Yeah. So this we plotted the milk consumed by the kid. Similar graph can be used for plotting population of a country. Similar plot can be used for plotting. Let's say if I have to let's say plot a kid's height every year, right? For initial 5 years, how the kid has grown between 5 to 6 years, 7 years, 8 years, let's say 9 years. Okay, so this is height. Let's say this is 1, 2, 3, 4, 5 feet. Okay, when the kid was 5 years old, 3 feet. 6 years old, 3.5 maybe, 3 feet 6 inches. It remained 3 feet 6 inches. The kid did not grow. In the 8th year, the kid grew very fast, became 4.5 inches, became 5 feet. So you can just plot any data against time like a bars. It's called bar chart. Yeah, you can have single bar chart. You can have double bar chart also. Let's say, okay, if you want to plot your no, say this growth also at the same time, you'll have two charts. This in blue, this one in, let's say, in purple. Okay, blue is you'll say blue is for Riddhi and no, purple is for Siddhi. Yeah,
Okay.
and you can plot the charts. Nothing fancy about it. It just gives you an intuitive view of the data in the form of bars. That's why it's called bar chart. And bar charts are very easy to read. I hope you have seen some bar charts in the past and you're clear about it. If not, let me know.
I
Have you
think
seen some bar charts?
yes. Yes. Yes.
And have you found them easy to read?
Yeah.
Okay, okay. So this is what. Now, second one is called pie chart. Pie, apple pie, banana pie, pineapple pie, whatever pie it is, or a pizza even. Yeah,
Right.
it's nothing but a circle. Yeah, and
Yeah.
if this circle or the pizza is distributed between two siblings like you and Siddhi, then this is Siddhi. Let's say I will say S, and this I'll say R. This is Siddhi's pie. This is Riddhi's pie. Yeah, 50-50. Done.
Yeah.
So we use this kind of data to okay, what happened here? Okay. So we use this kind of data to show the split. Let's say you guys order one pizza. Daddy says, I'm not hungry. I'll just have a small piece. Mommy says, I'm okay, not that hungry either. And Siddhi says, I'm feeling very sleepy. I'll just touch one slice. This becomes Siddhi's pie then. Yeah. This is mommy's. Daddy was not hungry that day. Siddhi was very sleepy. So here you can see that, okay, this is how it is split. So pie chart is nothing but it shows the split. Okay. Let's say you got 60% of the pizza that day. Okay. So this is your 60% of the circle. Mommy got maybe 20% of the pizza. So this is 20% of that one. And remaining 20% got split between daddy and Siddhi. Yeah. I'm just saying the names just to to make it sound more realistic to you. Okay. Otherwise, I mean it could be anything. Now let's say a pie chart is nothing but how a pie is divided. Pi is nothing but a circle here in our case, mathematically. So same thing can be used, say, okay, fine. In a class of 50 kids, okay, if you want to say 30% like science, 30%, 20% like math, okay, and remaining 50% students like social studies. Yeah. So this is how you'll plot it. So 50% is half of it. Now the only thing that we need to know about is that this circle makes how many degrees? 360 degrees, right? Yeah.
Yeah.
So that is how you have to always see how if most of the times pie chart will be very clear, showing how what percentage how the percentage is split. Okay, 50%, 20%, 30%, whatever percentage it is, right? You will use um, this total circle to split that. That's the whole purpose. Let's say somebody says distribute equally between boys and girls. Then you know, okay, fine. This is for boys, this is for girls. Yeah. I mean, let's say you guys got some gifts, and or let's say you guys got 200 euros to be split equally between boys and girls. Then you know, okay, 50%, 100 euros for boys, 100 for girls. If you want to depict that as a pie chart, you will just look at this pie and split that into two pieces half. This half is making 180 degree, this one is 180 degree. That is how together it is 360 degree. Tomorrow if situation is that, okay, distribute it equally among three kids, what you will do, you will split this into three kids. This is one, and this is one, this is one. All this is making how much? 120 degree. So that is how together is 360 degree. So basically, how you will split your pie will be like 360 degree is your total pie. 360 degree is 100%. Now, depending on how many percentage, how you are breaking it down, you will split this also. Let's say it's 2. So 360 degrees 50 100%. If you have to do 50-50, or I'll put it this way. 100% is 360 degree of the pie, full pie. 50% will be how much? Will be 360 divided by 100 into 50. Yeah. So this way you will be able to find out what portion of the pie is needed. But in simple terms, pie chart is nothing but it is just this tells you how things are split among different people, how you have to show the split within a group. Let's say government decides to distribute 2 million euros, okay, million euros between two departments or three departments. Okay, they say I will give 40% to education department, 30%, 35% to child welfare, and remaining 25%, 25% for construction. Now, this whole pie is 2 million euro. If you have to show this one, you have to find out what is 40% of 40% of 2 euro, or 40% of this pie. So 360, sorry, 100% of the pie is 360 degree. So 40% will be 360 by 100 into 40. And that will help you find out 36 into 4, 144. Okay. So 144 degree, this is what you have to draw. So one line from center, 144 degree will be somewhat this much. Okay. I mean, you can use the projector to find it out. So this is 144 degrees, or 40% of the money by government. So basically, what I'm trying to say here is your total pie has, if based on whatever percentage split that you have to show, you have to, if you have to find out the angle, this is how you will relate it. That okay, total pie is 360 degree, and if I have to uh, or 100% is 360 degree, whatever percentage I have to plot, I have to find out that degree and make that angle. So that tells me what size of the pie is for that particular thing. Am I making sense so far? Or are you clear with that?
Yes.
Okay, good. Okay, so we looked at pie chart, bar chart, and then there's something called pictograms. Okay, so pictogram is another way. You'll say, okay, fine. Let's say my drawing skills are not that great, but I'll still try plotting it. Okay, let's say for the year 2023, BMW and Bench. They BMW produced, let's say, 200,000 cars. Okay, and Benz produced, let's say, 250,000 cars. Okay, what they will do is they will draw the cars. Okay, this doesn't look like a BMW, but you have to trust me. Okay, so this is, so BMW, they'll say, okay, fine, this is my pictogram. Okay, so here every car picture represents 100,000. Okay, so here they'll say, okay, fine, this is how. So Benj will say, okay, I have two cars, every car representing uh, this, and then there's a half car. Um, you can see only one wheel. Okay, so this is nothing but representing data in the form of pictures. So Benz had 250 cars, 250,000 cars produced in 2023. So they put two and a half cars. Okay, so every car represents 100,000. So they'll say, okay, and the legend they will say, one car equals 100,000. Okay, so just by looking at this, you can derive interpretation. I mean, you can interpret what is the data. Okay, you don't have to read a big story. So that is called pictogram. I'm sure you would have seen some of these in your book as well. Yeah.
Yeah.
Okay. Then there are things like stem and leaf diagram, simple frequency distributions, or called dot plots. Um, have you dealt with them, or would you want me to talk through those? I'm just trying to see how much we can cover. We have just 4 more minutes. Okay, let's do one thing. Let's look at histogram. Okay, so we have looked at bar chart, pie chart, and uh, let's look at another thing called line graph, and then we'll look at histogram. These are two important ones. Okay, so let's say whatever we were doing, let's say for kids age, kids height with age, right? Let's say 5 years, 6 years, 7 years, 8 years, and we were plotting like a graph. Yeah, this is 1 feet, 2 feet, 3 feet, 4 feet, likewise, and we were doing this. Second option you have is you don't have to put if you don't want to put like a bar graph, you can also put it like no like what do you call, like you draw in a coordinate plane. Okay, when the kid was 5 year old, his or her height was 3 feet. When he or she became six, height became 3.5 feet. 7, height became 4 feet. At the age of 8, height was 5 feet. You can draw it like a line instead of making it like a graph. You can just identify those points and join them as lines, and that is called line graph. Yeah, is that clear? But between line graph and, see, this is my bar graph. Same thing, I'm plotting like a bar. Okay,
Okay.
and if I don't want to put a bar graph, yeah, I just put the numbers. Okay, when the kid was 5 years old, height was 5 feet. When the kid was 4 years old, the height was, sorry, when the kid was 7 years old, the height was 4 feet. When the kid was 6 years old, the height was 3.5. When the kid was 3 years old, height was, sorry, when the kid was, I'm confusing you. Sorry about that. Um, Look at this one. When the kid was 8 years old, the height was this. When the kid was 7 years old, height was this 4 feet. Okay. When the kid
Okay.
was 6 years old, height was, let's say, 3.5 feet. So I what I'm doing right now is I'm removing the bars and I'm plotting that as a points. Okay. For
Yeah.
every age, I'm looking at the height and identifying those points, and then I join those points. This is called a line graph.
Okay.
Earlier we had put like a bars. We are not putting bars. We are putting line, connecting the value and making that as a line. That's what is called line graph. Okay. There is one more thing that we can touch upon quickly, that is called histogram. Do you know what is histogram, or have you dealt with it?
Yeah.
It's nothing but something similar to the bar chart, just that here we deal with range instead of absolute value. Okay. Let's say if you have to plot how many kids got, this is 30, let's say 60. Out of, in an exam of 100, how many kids got this? Yeah, okay. In an exam of 100, how many kids got? This is, let's say, 0 to 40. Okay, here to here, 0 to 40. 40 to 80 is this one. 40 to 80. Okay, and this is 80 to 100. 100. Okay, if you want to plot, let's say there are 60 kids or 50 kids in the class.
Okay.
20 of them got 0 to 40 marks. Okay, out of 50. Ah, what is that? Total marks is 100. Sorry. And 0 to 40 was obtained by 20 kids. So this is 20 kids. Okay. In a class of 50 students, 0 to 40 was scored by 20 students. Another 20, let's say 25 students got 40 to 80.
Yeah.
Then only five got 80 to 100. So this here, if you see, right, we are not looking at exact number. We are not saying how many kids got 40. We are saying a range 0 to 40. How many kids got that? So when you're dealing with a range and plotting that like a graph, this is 40 to 80 students got, sorry, 25 students got 40 to 80. So this is a range 40 to 80, and this many students got it. Some would have got 41, some would have got 80. Yeah, also. So I'm saying this is a range. In this range, there are this many students. In 80 to 100, the kids who scored very well, that is a very small number. Only 5 kids got 80 to 100. So in an exam of with 100 marks, when we look at the data for 50 students, let's say this is the graph that we are plotting based on the scores. Okay. So this, the only difference between a bar chart and a histogram is bar chart gives you the bar plotted for exact value. Let's say you said okay, 1950, this was the population. You did not say this was the population from 1945 to 50. You said population in 1950, right? Say, but in the histogram, you're talking about a range. You don't talk about absolute value. So that's the difference. That's the only difference. Otherwise, bar chart and histograms look exactly the same. Yeah. So just a quick recap. Let's see what all we did. So we we looked at why do we need to deal with statistics? How does it help? How what is the difference between structured and unstructured data? And how the structured data gives us an intuitive view to derive some conclusion. Then we talked about the different examples with structured data, with tables, with charts and all, right? How it helps. Then we looked at the average and spread. That is where we talked about mean, median, mode, and then we start talking about different types of statistical tools like bar chart, pie chart, histogram, line graph. There are some more that is still remaining, but mm, this is the max we could do in a class today. If your exam is on 27th, right?
Yeah. It's on the 24th.
24th, which is Monday. So if you have any particular topic where you're getting confused, even if I'm not able to take class because I'm actually traveling,
Mm-hmm.
but if you have any particular topic within that subject, within that chapter, you can just tell me what which one is giving you some confusion. I can probably record an audio and send you something through your WhatsApp, just to give you an approach like how you can go about solving it. Okay, we'll try that and see if that helps. I know that there was not enough time because no statistics, if I have to cover, we would need at least 2 or 3 classes. I mean, otherwise no, we'll not be able to do
Yeah.
just with the amount of study we have to do. Yeah. Okay,
Yeah.
hope whatever we learned that today that helps with your test, and we will uh, and based on how it goes, you'll let me know so that
Yeah.
we can talk through what would be our next step going forward. Yeah. So I've stopped recording and I'll upload the video of the class in a bit so that you can